In question 3a, we're given rocks as a source of background radiation and asked for two other sources. Well, background radiation also comes from cosmic rays and from radon in the atmosphere. In B, a gamma ray detector with a cross-sectional area of 1.5 times 10 to the minus 3 square meters, when facing the source, is placed 0.18 meters from the source. There's a corrected count rate of 0.62 counts per second. In part 1, assuming the source emits only gamma rays uniformly in all directions, we're to show that the ratio of the number of gamma photons incident on the detector over the number of gamma photons produced by the source is about 4 times 10 to the minus 3. Well, this ratio equals the area of the detector divided by the area of a sphere this distance from the source. This is area of detector over 4 pi r squared, and putting in the values gives 3.7 times 10 to the minus 3, which is around 4 times 10 to the minus 3 as required. In part 2, the gamma detector detects 1 in 400 of the gamma photons incident on the facing surface of the detector. We're asked to find the activity of the source in an appropriate unit. Well, the activity is 400 times 0.62 divided by the ratio found above of 3.7 times 10 to the minus 3. This comes out at 6.7 times 10 to the 4, the units are becquerels. In C, we need to calculate the corrected count rate when the detector is moved 0.10 meters further from the source. Well, the intensity will obey the inverse square law, which is a constant over the separation squared. So the intensity times the separation squared will equal a constant, and so the initial intensity times the initial distance squared will equal the next intensity times that separation squared. Rearranging, and then we can put in the values, gives an intensity of 0.26 counts per second.